So, I want to review a little bit. B, abundant carbon dioxide produced plant growth and a rise in temperature ending the Ice Age. The lowering of the atmospheric temperature after the flood as a result of these atmospheric changes, as we discussed, especially in higher latitudes, certainly supplies a potent mechanism for initiating glaciation of continental magnitudes. But then the carbon dioxide remaining in the air would support only limited plant life as compared with the luxuriant pre-flood stands and there only limited animal life as well. However, in time, there is no doubt but that the shielding effect of the firmament canopy would have been at least in part restored by the formation of the following. Here's the dramatic and quick effect. The ozonosphere would have soon formed in essentially its present character. Once the new hydrologic circle was established and more or less stabilized, more important, as plants and animals began to grow again and gradually to multiply, their life processes would gradually restore carbon dioxide to the atmosphere, approaching the balance that has in general characterized present times. Along with this, carbon dioxide equilibrium between ocean and atmosphere required gradual discharge of the gas from the ocean into the air. Further, volcanic sources undoubtedly yielded, far limited to what caused the flood, but they still occurred, and we have historical evidence recently. So volcanic sources undoubtedly yielded a certain amount to the atmosphere. And all of this, in turn, would have caused a gradual rise in terrestrial temperatures, probably at an accelerating rate. What do you get? One might think from the destruction of plant and animal life on the Earth's surface by the deluge would likewise have enriched the air with CO2 rather than reduced it through burning and decomposition. However, most of the organic matter was evidently trapped in the sediments and buried, but undoubtedly many of the higher animals must have floated on the waters after death, finally decaying and thereby have contributed to the atmospheric reservoir of carbon dioxide. Likewise, much plant life also must have decayed on the surface without burial. There is no doubt, therefore, that in view of the sparsity of living organisms on the Earth in the early years after the flood, there was an excess of carbon dioxide over that necessary to support whatever life might be able to grow. And as the much reduced continental areas began to be repopulated by both plant and animal life, and as seawater gave up a portion of its excess CO2 into the atmosphere, it is highly likely and probable that the CO2 content of the atmosphere began to increase and thereby terrestrial temperatures likewise. We've heard today of global warming. Another factor may have also been involved. We have seen that a great amount of volcanic activity occurred during the flood. This activity, which is evidenced by the tremendous amounts of volcanic rocks found associated with the strata of all the geologic systems, must have released an indefinitely large amount of carbon dioxide gas. Much of this was released beneath the waters and probably contributed chemically to the formation of the extensive carbonate rock deposits, but also much may have been released above the ground and added to the atmospheric carbon reservoir. In addition, after the flood, although the high intensity of volcanic activity was restrained, there continued to be much more activity than occurs at present, as witnessed by the large amount of lava and ash beds that have been found, which can be reasonably attributed to the post-flood time period. All this produces what? More life. Although the volcanic eruptions thus may have made a substantial contribution to the post-deluge increment of CO2 in the air, this effect was undoubtedly masked and more than offset for a time by the fine dust that was also discharged in the air by the volcanic actions. This volcanic dust served to reduce the insolation, the amount of solar energy reaching the Earth's surface. In fact, let me put a period here. In fact, the volcanic dust discharged into the air by the intense volcanic activity near the beginning of the so-called period named Pleistocene has been one of the main theories advocated as an explanation of the glacial age. It may well have been a contributing factor, along with the removal of the ice canopy by the flood, to the initiation of the actual glaciation. Dr. Wexler of the U.S. Weather Bureau, one of the chief advocates of this theory, estimates that the solar radiation reaching the ground may be reduced by as much as 20% by volcanic dust after a severe eruption. As A.H. Wexler in his article. However, the volcanic dust, would have remained in the air only a few years at most. Speaking of the dust produced by the most prolific volcanic explosion of modern times, that of Krakatoa in the East Indies, the biochemist Asimov says, pretty nearly all that dust had settled back into Earth after 2 years. Isaac Asimov in his article. Now, the Krakatoa dust caused a definite lowering of temperatures for 2 or 3 years, but had no particular effect after that. The much more extensive volcanic activity of the deluge and post-deluge periods would probably have reduced temperatures for somewhat longer periods, but at best only a few years. Fix that. Fixing typos. This effect likely contributed to the initiation of the Ice Age, but the greater cause was the loss of the Earth's ice canopy, which protected the Earth, gave it mild temperatures, marvelous oxygenated air. Things grew tremendously bigger, as we see in the fossil record. But the carbon dioxide contributed by the volcanoes remained after the dust had settled, and combined with that already present and gradually, being added by the geological and oceanic exchange mechanisms to cause a gradual warming of the temperature of the Earth. Hence, goodbye glacier. One particular biological mechanism may have acted to contribute an abnormally large amount of carbon dioxide, namely the development of bogs. These are not the same as the familiar coastal salt marshes, but may form in uplands as well as low areas. The cool, moist conditions of the proglacial regions would have been unusually well suited for the development of bog lands. The best present peat bogs of the world are of great extent, in spite of great areas that have been drained or burned. George Jazakov, a Russian peat expert now living in this country, computes that there are 223 billion dry tons of peat available on Earth, more than half of it in the USSR. ESDB, Bog, Scientific American. The significance of large amounts of peat vegetation in fairly close proximity to the ice sheets is that they could have had a material influence on the accumulation of carbon dioxide in the air over the ice sheet, and probably over the whole world. It would have taken some decades or centuries for extensive bogs to develop around the ice, and it is likely that some other factors, such as volcanic carbon dioxide, increased atmospheric ozone, or carbon dioxide from biological mechanisms in general, would have initiated the warming. But this in turn may then have begun to oxidize the peat already developed and cause an accelerated warming, which in effect finally brought a relatively sudden termination to the Ice Age. Everything points to a termination of the Ice Age, and then it didn't reoccur like people maintain. Whatever may have been the detailed processes which initiated and terminated the great glaciations, it seems evident that the Great Flood provides an abundant, adequate ultimate explanation thereof. Don't need more than one glacier. Certainly, of the certain concepts as to the effect of carbon dioxide on the antediluvian and glacial climates are supported by the studies of Dr. Gilbert Plass of Johns Hopkins University, whose work is sponsored by the Office of Naval Research and probably the greatest present authority on the subject. He says, for example, that's what he says, there is some interesting evidence which suggests that the carbon dioxide content of the atmosphere was once much larger than at present. It is known that plants grow more luxuriantly and rapidly in an atmosphere that has from 5 to 10 times the normal carbon dioxide amount. In fact, carbon dioxide is sometimes released in greenhouses in order to promote growth. Since plants are perfectly adapted to make maximum use of the spectral range and intensity of the light that reaches them from the sun for photosynthesis, it seems strange that they are not better adapted to the present carbon dioxide content in the atmosphere. The simplest explanation of this fact is that the plants evolved at a time when the carbon dioxide concentration was considerably higher than it is today, and that it was global warming. What happened? And that it has been at a higher level during most of the ensuing time. higher temperatures than today during most of the Earth's history would have resulted in this higher carbon dioxide content. In fact, the geological evidence shows that warmer climates than today have existed for at least 9/10 of the time since the Cambrian period. What happened? That's not uniformitarianism. Things were different then. Did they address that? No. So, post-flood period continuing. Summary. We have a summary, folks. I know this is very complex, but isn't this amazing? We can look around our planet and get this information without being rocket scientists. Just read some here and there. Glaciation was only one of the after effects of the deluge, though undoubtedly the most spectacular. Tree rings indicate a recent catastrophic flood on recent Earth. I just saw something on television the other day about how you can tell each year how trees, what season it was for these trees. But the problem is there are different fluctuations that go not in 1 year, but less than a year, weeks, couple of months, whatever. There might be some dramatic changes, catastrophic things, sudden things that come and go. That's not a yearly tree ring. So you can't declare that's 365 days every time. One valuable natural chronometric device is the common tree and its annual growth rings and their patterns. Both living and dead trees can be used in this science known as dendrochronology. Perhaps the most intriguing of the unanswered questions regarding longevity in conifers, evergreen trees, has to do with Sequoia gigantea trees, which some believe may enjoy perpetual life in the absence of gross destruction since they appear immune to pest attack. Does this mean that shortly preceding 3,275 years ago, the age of the oldest conifers, all the then living giant sequoias were wiped out by some catastrophe, like the flood? Ah. Edwin Schulman, Longevity Under Adversity in Conifers. There's a question. We have no evidence. Nobody was there to gauge, measure. Microscopic study of growth rings reveals that a bristlecone pine tree found last summer at nearly 10,000 feet began growing more than 4,600 years ago, and thus surpasses the oldest known sequoia by many centuries. Many of its neighbors are nearly as old. We have now dated 117 bristlecone pines 4,000 years old or more. Okay, let's see if that can be actually accurate. Edwin Schulman. Since these, as well as the sequoias and other ancient trees, are still living, it is pertinent to ask why these oldest living things apparently have had time to develop only one generation since they acquired their present stands at some time after the deluge. There is no record of a tree or any other living thing being older than any reasonable date for the deluge. Interesting. So why all those rings? See? Exactly. Were you there? Historical records indicate a recent civilization, not an old, evolved one. In the last analysis, the only really reliable recorder of time is man himself. In any kind of natural process that might be used to determine past time, there is always the possibility that the rates may have changed, as well as uncertainty regarding its initial condition. It is absolutely impossible to know beyond question that such and such a formation or deposit or sequoia tree has an age of so many years, unless that age is supported by reliable human records of some kind. And it is therefore highly significant that no truly verified archaeological datings antedate the time of about 3000 BC or even later. Larger dates are, of course, frequently ascribed to various localities and cultures, but they are always based on radiocarbon and other geological methods rather than written human records. But you know, radiocarbon, carbon-14, has not reached maximization yet, concentration, so we don't know for sure. It still shows increasing capacity, or still a remaining capacity to reach total saturation, carbon-14 in the atmosphere. And it only goes up to, what, 20, 30, 40,000 years at the most? There are numerous extant chronologies that have been handed down from various ancient peoples, and it is bound to be significant that none of them yield acceptable evidence that the histories of these and other peoples antedate